Okay, so hopefully everyone is back at their desks after that quick break. Dave has asked me to kick off the next session, which is going to be the Early Career Researcher Flash Talks. I'd like to thank everyone for joining and also say that I'm really pleased to share this session. Like everyone else who's been talking, I'd also like to say it's so nice to see some names of some good friends on here. And to those of you who are new, I'd say that the DAB really is a place that is worth missing, because you get to encounter all these weird and wonderful research topics that help stimulate your ideas about your own work, such as mine, which is on large dams. I'm going to paste in the chat who I am, so you can read about me if you care. And if you are new, do reach out, because I'd love to meet you online. I've met some, but not all of our presenters today, and their diversity really showcases how different we all are in the DAB. We've got something on carnivores and something on concrete, something on butterflies, thoracic temperature, and cutting-edge forest detection techniques as well. But all these talks and all of the themes are somehow still aligned under the UCCRI, and I think that's one of the great things about being in the DAB. Just in case you've just joined, a bit of a housekeeping refresh. Please mute your mic and make sure that your video is turned off during the actual talks. The presentations will be very short, just 5 minutes long, and there'll be a very constrained period to ask questions afterwards. So I would remind you that Zoom's quite brutal. I'll just have to cut you off if you're talking too long, so try and keep it short and sweet in your questions as well. Like the other chairs, I'd like you to write in the chat if you'd like to ask a question or a comment, and then you'll be unmuted to ask your question or comment. And without further ado, as we are running late, I'd like to invite Dr. Toby Jackson from the Plant Sciences Department to begin his talk. I think he's got a presentation to share.
I have. Okay. So I am Toby Jackson. I'm a postdoc with, I need to go back. I'm a postdoc with David Coombs, and I'm talking to you from Ethiopia, and my internet can be unstable, so apologies. So I wanted to talk to you about a project which I'm quite excited about at the moment, which is Repeat LiDAR. So I'm assuming you've all read a lot about LiDAR or read something about LiDAR. So this map on the left is a map of carbon density in Sabah in Malaysia. So this is an area about half the size of England, a bit over. And it's basically a map of how much carbon the forests are storing. And what's really good about this map is that we can distinguish the really high dense carbon areas from the medium density carbon areas, which you can't do from most satellites. So that's what's really good about LiDAR. But the next cool thing is going to be repeat LiDAR, and that's going to be very useful for forest ecology in the future. So this on the right here is a slice through some LiDAR data. And the data in green was collected also in Sabah in 2013. And the data in pink is from 2020. This is just a screenshot of some data which I'm waiting to receive and excited about playing with. And what you can see is that over the 7 years, this tree has grown quite a lot. This tree is about 60 meters tall. And so it's grown by a few meters, the pink. And then also you can see on the sides, there's green areas which have disappeared. So some things have disappeared in the intervening time. So the good thing about repeat LiDAR is that we can see the changes and therefore the processes which are going on. So jumping over to the other side of the world, here's some data from French Guiana, a plot called Nurag, and we have 28 square kilometers of LiDAR data here. So if you just look at the top left, the 2016 data, this is just a top-down view here. And so you can see the trees from above. And if you can see my cursor, there's a tree here, which then in 2019 has disappeared. So again, you can see changes. And then in this one here, the blue stuff is the trees growing up, and the red stuff is the trees disappearing. So it's great in terms of studying changes over time. And we can do that spatially like this. We can average over certain areas and look at spatial statistics. But what would be really cool is if we can look at changes at the individual tree level. And that would help us a lot to understand the mechanisms which are going on. So this is what I've attempted to do here with some caveats. And so essentially on the left are trees growing. So the axis on the left here is the original height of these trees. So these were short trees in 2016, and you can see their crown diameter. And these ones, the color here is how much carbon they've gained between 2016 and 2019. And then the same on the right for trees which have died. So yeah, I think this is going to be a really cool tool, but there are still some challenges. You'll notice I haven't put a scale on my numbers of carbon here because I'm still working that one out. So one of the main challenges is working out distinguishing whether these are individual trees or not. So we have algorithms to do this, but they're not perfect. And so at the moment, lots of these things are what we think are individual trees, but we're not wholly confident. So that's one challenge. Another challenge is to validate this against field data. Obviously, that's going to be important because of our, and it's going to be important to do that at the right kind of temporal resolution. So here we have 3 years in between scans. And then the next most important thing is to identify the drivers of these changes, because that's going to help us answer some big ecological questions about large tree mortality rates. So one of the key things which we don't understand about forest ecology at the moment is what's the mortality rate of the big trees, because they account for a lot of carbon and we don't really know the drivers. So this repeat LiDAR can really help us answer those questions, and I'm quite excited about it. So if you want to contact me about it, my email is tj312, or ask me any questions. Thank you very much.
To much more fine-scale temperature patterns. And these kind of fine-scale temperatures are what we term microclimates, and these can be decoupled from even quite local air temperature by structural variation in the landscape. So that could be generated by topography, it could be generated by vegetation, it could be generated by shelter. And so, it's already been shown that landscapes with more diverse microclimates are able to retain more species over a long period of time. So it's important for us to understand how individual animals are responding to these fine-scale temperature changes, temperature patterns, and how this might play out into their long-term population trends. So to try and get at this, we looked at a couple of questions. This is kind of a subset of the paper because it's quite a short talk. So we wanted to look at whether different species of butterflies within a community use different thermoregulatory strategies, and whether these individual level responses are related to species long-term population trends. So to do this, we went out onto some reserves across the UK, primarily in Bedfordshire, and caught about a few hundred, about 1,000 butterflies in nets and took their temperatures. And we actually took 3 temperatures from them. We took a temperature from the butterfly itself, from its thorax, a temperature from the perch, which it was using at the time of capture, and a concurrent air temperature in the shade at waist height. And what we hypothesized was that we could probably break down a butterfly's thermoregulation into 2 components. So one would be that a butterfly could choose to use a microclimate, which is a different temperature from the surrounding air temperature. And we measured this by taking the temperature of the butterfly's perch and subtracting the surrounding air temperature to see what difference the butterfly was getting from that. And secondly, we hypothesized that we use behavioral thermoregulation. So this would be angling their wings perhaps to warm themselves up or cool themselves down. And so to get a measure on this would be taking them to a different temperature beyond their perch temperature. So we measured their thoracic temperature and subtracted their perch temperature. And we then took these 2 variables and plotted them against each other to see how this varied across the community. And what you can see here is that all species actually showed some level of behavioral thermoregulation above that of their microclimate selection, because all of the points are above the dotted line of parity. But actually some species, those closest to the line down here, like the small teeth, have to select favourable microclimates and rely much more on selecting favourable microclimates to alter their body temperature. Whereas species that are further away from the line, such as the comma up here, are better able to alter their body temperature beyond that of their immediate surroundings. So we might term these second group of species, including the comma, as thermal generalists, because they're relatively robust to changes in their temperature, in the temperature of their environment. and the species like the small heath as thermal specialists because they're quite sensitive and dependent on the temperature of their environment. So we then wanted to see whether these individual level responses related to population trends. So we calculated the difference between the behavioural thermoregulation and the microclimate selection, that's on the x-axis, and plotted this against the long-term population trends from the UK Butterfly Monitoring Scheme. And what we found was that these two things were significantly associated. So species that were more reliant on microclimate selection have suffered greater population declines over the last 40 years. So to put that in context, we've got the small heath that I showed you before, just down here, compared to the comma, which is up here, which is doing quite well. So just to summarise, understanding individual thermal tolerances is really crucial to informing our predictions of how species are going to respond to climate change on a broader scale. We found that the thermoregulatory strategies of butterflies differs across a community, and we've highlighted a few thermal specialists which rely on microclimates for their thermoregulation. And these are likely to be species that are particularly sensitive to climate change and might need more conservation action in the future. So I'll just end with a quick slide to thank all of our collaborators and co-authors, and thank you for listening.
Thank you very much. That's really fascinating work and really important, I think, because these behavioural changes are where the kind of slack is in terms of adaptation. We don't have any questions in the chat, but I think I would just ask one question, which is, did you get any funny looks, like running around Bedfordshire, chasing after butterflies with, I imagine you had like a mercury kind of thermometer that you were trying to put in the mouth of the butterflies?
It was actually, it's a fine scale temperature probe. So it's a little thermocouple on the end of the wire. Yeah, surprisingly few actually. An amazing number of dog walkers just don't pay a blind bit of attention, and then the odd couple kind of come over and ask you what you're doing. But yeah, largely completely ignored, which is very odd.
It's always good to know. Okay, with that, if we hand over to Valerio, who is going to talk about carnivores. I don't know if you have.
Hello, can you hear me fine?
Yeah, we can hear you.
I'm going to try to share the screen now. Right. Is it working? Can you see my PowerPoint?
Yeah. No, we can't. We can see your desktop. I just thought that was a...
Right. So now I should be on the PowerPoint slide.
Yeah. Now we're on the PowerPoint, and now you're presenting.
Let me know if it doesn't progress with the slides, and I just leave the presentation. Right. So basically, I've just started my PhD at Cambridge, and I'm with Chris Sandbrook, and this talk can kind of go over a little bit about what coexistence is between people and large carnivores, or at least the concept of coexistence is. So just very briefly, for a matter of time, what are human-carnivore conflicts? So they tend to occur for two main reasons. Obviously, like the first reasons, it's quite obvious that carnivores can have quite serious impacts on people, from killing livestock to instilling fear in people and killing people. And then there are more complex and kind of like cryptic reasons as well. There are social reasons usually. So perhaps marginalized communities may associate carnivores to symbols of oppression to carnivores, or symbols of urban elitism to carnivores, and that can lead to conflict per se, with all sort of consequences, from the decline of large carnivore populations to impacts on the livelihoods and well-being of people. And so generally, like, the management and policy response to these conflicts is trying to pursue coexistence or aim at some sort of coexistence. And so I started wondering, like, what exactly is coexistence? So just going by the definition of the Oxford Dictionary, to exist at the same time or place, which is more of a what definition, I'd say. And then they also have another one up, which is to be together in harmony. And that, again, I think that's more of how, the definition of coexistence. So I was just thinking, how can we apply this to human-carnivore coexistence, to the concept of coexistence? And I guess if you want to go by the what definition, then we can say that it's about trying and ensure the co-occurrence of people and large carnivores in the long term, without one or the other going extinct or to die out. And so you can associate that to some extent and to something akin to sustainability. But that doesn't tell us much about how we should be trying and encouraging this coexistence or manage this coexistence. And for that reason, I think it has to fall back to the second definition from Oxford Dictionary, which is in harmony, to be together in harmony. But even then, people may have different conceptions of harmony. And I guess it doesn't really tell us much about harmony between what or who. So this is why I'm saying that, generally I think that the concept of coexistence tends to be quite value-laden. And I guess the way you approach it depends a lot on your values. So if you align yourself more with ecocentric values, generally speaking, I'd say that you possibly are more focused on interspecies justice. So you might be looking at cost and benefits of coexistence between people and wildlife. So who are the winners, who are the losers, is wildlife, paying too much of a bigger price compared to people. And this might affect, decision and thresholds such as the favorable conservation status or minimum viable population thresholds. But on the other hand, this might also mean that you might promote more of a prevention-based management and trying to minimize the impact that you're having on wildlife to even out those costs and benefits between people and wildlife. On the other hand, I guess if you tend to have more anthropocentric values, then you might feel more about social, focus more about social justice. And you might still do the cost and benefits analysis, but rather than focusing on people and wildlife, you might focus it on more on people in general, different groups of people. And it's particularly relevant in this context to do some kind of cost and benefits analysis, because obviously some people have much of a greater burden because they are the ones that actually live with carnivores, while other people not necessarily live on the territory, but they still might have some values that push them to pursue some kind of coexistence that they have in their mind, especially of specific kinds if perhaps you align with ecocentric values. And this can lead to all sorts of things, including issues such as neocolonialism, for instance, where people from the global north dictate to people of the global south how they should manage their wildlife. And there have been approaches that trying to kind of merge these two values, such as just conservation, but these still tend to lean towards a kind of weak anthropocentrism. So just concluding, I think that a lot of coexistence comes down to our own values. And I think it is crucial to understand and acknowledge this value plurality out there to better understand her and also scrutinize power relation and power dynamics to try and figure out whose ideals of existence is it the management is pursuing. Is it just because they're in position of power that we're pursuing those kind of ideals? And this is the kind of research I'm going to be doing in this PhD, which I've just started, and I'm going to be focusing on wolves and farmers in Italy specifically. And lastly, I want to leave you with a question. What do you think is your ideal of coexistence? Thank you.
Thank you very much. No, that's a really interesting, also last question to leave us with. We don't seem to have any questions, but we do have a few minutes. So I was wondering if you could elaborate a bit more about your methodology as you're at the beginning of your PhD. Especially around how you might determine power relations and whether you were talking about power relations between humans, non-humans, or between humans with respect to power relations.
Yes, obviously this presentation was quite time constraining, so I can't go through all this, but I'm going to be approaching this research from a political ecology perspective. So I'm going to be using methods, ethnography, policy analysis as well, perhaps some archive research. And I'm going to be looking at power dynamics between, mostly between people groups, groups of people, and not just between, let's say, conservationists and farmers, but also amongst conservationists and amongst farmers. So perhaps farmers that have bigger farms might have more political power and a bigger voice. The farmers that are quite small. And paradoxically, that means that coexistence might favor the views of farmers with bigger farms. In a way, and I guess it's not just about coexistence, it's more in general also about trying to figure out what is the best way forward for effective conservation overall.
Thank you, that's really interesting. Actually, Michael Overton had a question. I don't know if you want to unmute yourself, Michael, or maybe a comment. No, it's a comment and a question.
Hi, yeah, it's a question. I'm curious about which groups you might be speaking to in Italy. You talked about the farmers. I'll just read out what I wrote in the thing. It might be argued that some hunters are ecocentric, although their ideal of ecosystem might differ from that of an ecologist. Are you likely to speak to hunters as a main group in Italy?
So if I got it right, because it was a bit like lagging, but if you're asking if hunters are mainly ecocentrics, is that right?
I think it's a positive. You could stretch the definition of ecocentrism to a hunter's kind of group of beliefs, I suppose. But are they of interest? Are hunters as a research group as a population, research population of interest to you?
Well, I guess you know, there isn't a specific way of defining ecocentrism. I guess people can approach it from different angles, and definitely, like when you look at hunters specifically, you know, some of them do actually feel that they have a very respectful relationship with wildlife, and you know, hunting them, it's part of you know, a natural process that they've been sharing with wildlife for, you know, since Homo sapiens, since our species really has been around. So there's literally nothing potentially wrong with hunting. And in that sense, yes, you can say that they value, you know, wildlife in a different ways that we do. But I feel like from my perspective, again, I'm quite new to this topic, so my perspective might change, but I feel like ecocentrism is more to do with interspecies justice. So perhaps you wouldn't necessarily be too much concerned about whether hunting is right or wrong per se, but you'll be more concerned about the impact you're having on wildlife. So for instance, you wouldn't necessarily be, you know, if someone was saying, I value hunting people, you will never be like, okay, fair enough, I acknowledge your values. So the reason why you might say, well, why some people say, well, that's not acceptable to be hunting animals, is because they kind of like assign personhood to animals as well, perhaps, or extend the concept of social justice to species as well. So it becomes kind of like a little bit more ecocentric, which again, because it's down to values, it's quite hard to tackle from a practical perspective unless you know, look for those power dynamics and kind of that stuff.
Okay, thank you very much for those final reflections. That's all we've got time for. I have to say I feel very smug because we're now at 4:15, which is where we should be. I suggest that we take another couple of minute break just to grab an extra cup of tea before our next session, which will be on new perspectives on nature-based solutions from CCI, which will be a conversation between David Coombs and Mike Maunder. But everyone give our early career researchers a round of applause. Thank you very much, guys. That was super interesting.
And thank you, Lucy.